actual. Okay, so quickly here, we know that this is a shift from the parent function 1 over x. Correct, everybody? Yeah. Okay, so we're going right 3. Right 3, so we have an asymptote at right 3, correct? A vertical asymptote. Okay, we're going to see more vertical asymptotes today, and up 4. So we have a horizontal asymptote at up 4. And then after that, we would just plot x, y points, correct? Yes. Now I'm going to make a point here. Is there going to be an x-intercept? Is there an asymptote on the x-axis? Yes, there's not an asymptote, so yes, there's going to be an x-intercept, correct? That's when y equals 0. And then look on the y-axis, there'll be also a y-intercept because there's not an asymptote on it. That's when x equals 0. So if we plug in y equals 0, that would be 0 is equal to 1 over x minus 3 plus 4. We're trying to find just x, y points. That's all we're doing right now is plotting points. You guys understand that, right? Yeah. I'm just plotting points. I'm just plotting specific points so that on the test I can get that right when I say, what's the y-intercept? Does that make sense, everybody? Okay, so then let's solve for x. Subtract 4. Negative 4 is equal to 1 over x minus 3. And you say, I'm trying to solve for x. I need a common denominator. Multiply by x minus 3 over x minus 3. Our denominators are now the same. So we would distribute that negative 4 through. Negative 4x plus 12 equals 1. Solving for x, we'll subtract 12. So we have negative 4x equals negative 11, correct? Give me the decimal, divide by negative 4. Go, quickly, give me the decimal. We like decimals when plotting points better. Okay, so 2.75. So let's do that. Let's plot that. That's over 2.75 up 0. So over 2.75, about right there, and up 0. Sweet. Now let's do our y-intercept. So that's when x equals 0. Let's plug in 0. That's 1 over 0 minus 3 plus 4. Calculate that. That's just 1 over negative 3 plus 4. So you'll go 1 divided by negative 3. Hit enter. Then plus 4. What's the decimal? 4 should be 3.6, correct? It's negative, so 3.6. So we're going over 0 up 3.6. So there's where it's crossing the y-axis. So don't we know on this half of the graph, we know that it's coming down by this asymptote and up by this asymptote, correct, everybody? Yeah. Now notice we don't know what's happening on this side of the asymptote. We don't know what our graph's doing. So let's plot up another point. In your XY chart, we're just going to add in another point. Let's do one on this side. So this was 3, correct? Let's plug in 4 into our equation. We're just plotting points. So we have 1 over 4 minus 3 plus 4. So 1 over 1, right? Which is 1 plus 4, which is 5. So now you'll plot that point. Over 4 up 5, over 4 up 5. So now you know it's up here in this region of the graph. So we'll come up by this asymptote and down by this asymptote. Questions? So it's just pretty simple. I mean, there's a lot to think about, but not hopefully too bad. If you understand that, today won't be as hard. So recall that some rational functions are a shift from the parent function, and some are not. We talked about this last time. So just look. This is our parent function. This would be a transformation from the parent function. That's what we learned how to graph last time. This is not a transformation from the parent function because there's 2 x's. Does everybody understand? You're going to graph those a little differently, but there's going to be a lot of the similarities. So I just want to make sure that we're good. We're going to recall some key features that you're going to see again on the non-shifted rational. So first of all, we know that we cannot divide by 0, correct? That is a value in our domain that cannot happen. Does everybody understand? So when are we going to divide by 0? X is equal to what? 3. That would be dividing by 0. So we've got to say x cannot equal 3. That's why we have a vertical asymptote at x equals 3, because then it won't cross it. Everybody good with that? We're going to see vertical asymptotes the very same for the very same reason on the next lesson. If it's on bottom, then we'll have a vertical asymptote because we can't be that value on bottom to make it 0. Does that make sense? Okay? And then we know that asymptotes are where functions get really, really close to but don't usually cross. Now, however, they will never cross your vertical asymptotes. Here and there, they will cross the horizontal asymptotes. But even if they do, let's pretend, even though this one doesn't, let's pretend this came up here like this and then it did eventually cross. It's still going to hug the asymptote. Does that make sense, everybody? Okay, so what is our domain? It has everything to do with our asymptote. So domain is left and right. So you would say domain is x cannot equal 3, correct? In interval notation, that would be from negative infinity up to 3, from 3 to infinity. Does everybody understand that? Right, look at our graph, negative infinity up to 3, these are x values, correct? And then from 3 to infinity. That is the advanced way of writing it. That's how my honor students write it. This is how regular writes it. So why not be both? Because you could see either on your ACT. So let's all be prepared. And next year in pre-calculus, you'll see this notation. So why not just prepare you? It's not too bad, right? Okay, range is y values, all possible y values of your function. So this one's growing from negative infinity up to 0, and then from 0 to infinity. So y cannot equal 0, correct? An asymptote there. So once again, negative infinity up to 0, and then union 0 to infinity. Okay, questions on that? So you're going to see those key features on these. So here we go. These are non-shifted functions. We're going to look at a couple of different things that are going to happen. We've got to know some new notation. There's quite a bit, but hopefully I'll help make sense of it, and then it will be pretty easy. So non-shifted rational graphs have a few similar key features and a few different key features. So we're going to first talk about a new word called discontinuities. So a discontinuity is when the denominator, the bottom of your fraction, is equal to 0. That's what makes our graph discontinuous. So this is an example of a rational that is not a shift from the parent function, as you can see, correct? That is continuous. Now here's why. So let's look at this particular function's discontinuities. That's when the bottom equals 0. So we would say x squared plus 1 equals 0. Let's solve and figure out when is x going to equal 0. I'm going to do it on my whiteboard. So we got x is equal to, now this is going to make sense, just wait, x is equal to plus or minus I, that would make the bottom 0, correct everybody? Now we're not dealing with imaginary numbers. If we're plotting points, that's on the real number line. So we're not going to be dealing with imaginary numbers. So there's no real number that makes the bottom 0. Does everybody understand? There's no place this is ever going to equal 0. We can literally plug in any real number. Does that make sense, everybody? Okay, so we would throw that out because we're not dealing with imaginary, so there's no real number that makes the bottom 0. So look at the graph. Do you see how this is continuous? It never stops. I never have to pick up my pencil when tracing it. That's what makes it continuous. Why is it continuous? Because there's no discontinuities, which are when the bottom equals 0. Does everybody understand that piece somewhat? Yes? Okay. Okay, so notice there is no vertical asymptotes because they can be any x value. Everybody good with that? Okay, so now we're going to talk about when a graph will have a hole, which is a discontinuity. So everybody look at this picture right here. Do you see how if I draw in the graph, right here there's a hole, so I have to pick up my pencil and then keep drawing. That is a discontinuous graph because I had to pick up my pencil. Does everybody understand? Okay, so there's a break. That's a hole in the graph. Now here's where the hole comes from. So a hole is a discontinuity. Discontinuities are what make the bottom equal to 0. So let's look at this and just say, what's our discontinuity? So we'll say x plus 2, when does that equal 0? Solve for x, subtract 2. So x cannot equal negative 2. Everybody understands that that's my discontinuity, correct? Okay, now this is why it's a hole. Do you see how now that we have we've restricted the domain, we will divide out that x plus 2. And that leaves us with x plus 3. So do you see how I removed the discontinuity? I divided it out, I removed it. That's called a removable discontinuity. So now, because it was removed, it's a hole in the graph, not a vertical asymptote. It's a hole in the graph. And we could get into why that is. That's because, but it's going to just be like, it's not even, you're not going to use y. So we don't have time today to get into y, but here's basically why. We could redefine the function at negative 2. So we could say, let negative 2 be equal to 1, and that's just too much to think about for us at this level. So, does everybody understand? If it divides out, the discontinuity divides out, it doesn't create an asymptote, it creates a hole in the graph. Okay, that's just a rule you gotta learn. So there it is, there's the rule. So now hole is at, notice this hole is at a point, an xy point. It's negative 2 up 1. Well, how did we know to go up 1? This is how. So we knew our discontinuity was at negative 2. So we knew we had a hole because it divided out. So we would say our hole is at a certain xy point, negative 2 comma something. Yes? It's a vertical asymptote. Yep, so we'll do that one next. So now that we say, okay, -2 is where my x equals -2 is where my hole is at, but I don't know how high up, because what if it was at -2 down 1? Does that make sense, everybody? So what you'll do is look back at the simplified answer, which is x plus 3, plug in -2, because I'm saying, what is my function at -2? Does everybody understand? Plug in -2. What's -2 plus 3? 1. So our hole is at an xy point, -2 up 1, which makes sense. There it is. So we would draw that in. Okay? So you'll have a hole if you have a removable discontinuity. I remove it. Then it's a hole. Okay, so looking over here, instead of a hole, it will make a vertical asymptote at the discontinuity if it doesn't divide out. So look at this example. It's not a shift from the parent function. You would say to yourself, what is my discontinuity? That's when my bottom equals 0. So x minus 2 equals 0, solve for x. X cannot equal 2, correct? So you'd say, is it a hole? Does x minus 2 divide out with anything on top? No, so you can't remove it. It is there always. That is there. It's a vertical asymptote because x will never equal 2. So look, you see that I have a vertical asymptote at x equals 2. So that's literally our first step. So if it doesn't divide out, it's going to make a vertical asymptote. That's our first step to graphing these. Figure out the discontinuities, holes or vertical asymptotes. Everybody good with that? Okay, awesome. Do you need to take a picture of this? Anybody want one? Okay, awesome. I'll push pause and I'm going to keep talking. So now it's our last thing to learn, and then we can just start basically practicing. So now we just learned how to figure out our vertical asymptote. Now I'm telling you how to get your horizontal asymptote, which is this way, of a non-shifted function. So to get your horizontal asymptote of a non-shifted rational function, you will actually just divide the polynomials. So let's look at this. X minus 5 divided by x plus 4. Let's do long division, okay, real quick. So here we go. We're going to put out x plus 4 on the outside. It's really not bad. And then you're going to see a pattern happening, and then you'll use the pattern. So that's what goes on the outside of our house. What we're dividing goes underneath. So I'm doing this to make sense to you. So we always divide our leading coefficients, correct? We do our bulletin. We're doing this divided by this. Does everybody understand? X divided by x equals 1. So we put 1 on top. Didn't it divide evenly, perfectly? It divided evenly, no x left, correct? Okay, interesting. Now if we kept going with long division, remember we multiply this back down. So that would be x plus 4, and then I'm glad Riker remembered we need to change our signs. We add straight down. So that'll be 0 minus 9. Now look, does -9 divide by x at all? No, 0 times. So isn't this our remainder? So we have 1 with a remainder of -9. Now when graphing, we just discard the remainder. So we will have a horizontal asymptote at y equals 1. Then we would draw that in at 1 on the graph. Does everybody understand? Yeah. So did you notice something interesting here? Degree 1, degree 1. If they have the same degree, then they'll divide evenly, correct? So if they divide evenly, can't we just divide the leading coefficients? Because the rest will be a remainder. We divided the leading coefficients and got something without an x. So won't the rest be a remainder once we keep going? Does everybody get that? So you'd only have to divide the leading coefficients. So we'll just do 1 over 1, which is 1. Does that make sense, everybody? Okay, let's do this one then. Okay, so look right here. Leading term is 2x squared and leading term is 4x squared. Aren't we going to divide evenly with no x when we divide the leading terms? So that'll be 2 divided by 4, which is 0.5, which is a half, correct? So then when we put a half on top and we multiply it back down, won't the rest be a remainder since there was no variable? So our horizontal asymptote will be at y equals 1/2 because it divided evenly. The degrees were the same, so they'll divide out perfectly. Does everybody get where I get a half from? So we go up a half and draw in our horizontal asymptote. Okay, look at this one. This one always tends to get people. We have x minus 3 divided by x squared plus 3x. So once again, if we put this on the outside of our house, put this underneath. No, wrong. Sorry, this is what we're dividing by, correct? So this should be outside our house. X squared plus 3x, and underneath is x minus 3. So if we go up and focus on the leading terms, x divided by x squared. Does that divide at all? 0 times, correct? So y equals 0 would be our horizontal asymptote. So it didn't divide at all, so it was 0. Yes? No, no. And if it doesn't divide evenly, then we'd say 0 for these. Does everybody understand? Okay. That's all you gotta know. So here are the step-by-step instructions to graphing a non-shifted rational function. Do you need a picture of this? This is a great picture to have because if you ever get to the test review and say, I don't remember how to graph these, you should refer back to this and then you'll remember, oh yeah, I remember doing those steps when we practiced. So you just follow these instructions. So first look at your discontinuities to find holes in vertical asymptotes. So just look at these. We would say, okay, where's our discontinuities? That's when the bottom equals 0. So x equals 2 is a discontinuity, correct? And x equals 3 is a discontinuity. Is everybody caught up mentally with me? Now let's decide if that's a whole or vertical asymptote real quick. Does the x minus 2 divide out? No, so this would be a vertical asymptote. Does everybody understand? Does x minus 3 divide out? Yes. So this would be a whole. Everybody good? Yes. So then we'll keep doing that in a minute. So looking at this one, our discontinuities are at x equals -1. Is it a whole or a vertical asymptote? It's a whole. It divides out. So we'd say whole. And then looking at this example, we would have x equals 5 as a discontinuity and x equals 6. Are they wholes or vertical asymptotes? Vertical asymptote. They didn't divide out. Everybody good? That's all you got to be able to do, and then you draw it in. That easy. Move on to your second step. Find your horizontal asymptote by dividing the functions. X divided by x squared, how many times does that divide? 0. So we have a horizontal asymptote at y equals 0. Okay, then we draw that in. Then after that, we're just plotting points. So do you see how it's very similar, just a little bit more to think about? X minus 3 divided by 2x, the leading terms is what we would be dividing by. Do they divide evenly without an x? 1/2? 1 over 2? So we'd have a horizontal asymptote at 1/2. We fill out the half, draw it in. Right here, 4x plus 1 divided by 2x, we would have a horizontal asymptote at y equals 2. 4 divided by 2. Everybody good with that? Okay, once you found all your asymptotes, it's just literally plotting xy points just like before. If there's an x-intercept, find that. If there's a y-intercept, find that. And then you can graph as many other points as you want to be able to draw a correct graph. You're going to be plotting a lot more points for this one, just to be more certain what your graph looks like. Then we're going to find the domain and range, and remember it will relate to those asymptotes. Let's start practicing. Here's my first example. So you can just watch, you can get out your little whiteboard and draw some in. But once again, these are not off the worksheet because I didn't give you that many to do as it is, and you need to practice. All right, so maybe take some notes on the back page or something of your packet. I would, if I was you. Maybe write down the problem, write down at least the vertical asymptote poles and stuff really quick. Just on the back of your packet, isn't there a blank page? I would just take some notes. Okay, so we're going to graph this function. So your first step is figure out vertical asymptotes and holes. So that is when those are our discontinuities. That's when the bottom equals 0. Well, look, this is not factored. So let's quickly factor this very quickly. So let's rewrite this function one more time as in factored form. We have x plus 3 on top. Let's quickly do it. We'll multiply it to be 3 and adds up to be -4. What? 1 times 3, negative. So this bottom factors to be x minus 1 and x minus 3. Is anybody confused at all yet? You got to be honest with me today. So you say to yourself, where are my discontinuities? That's when the bottom equals 0. X equals 1 is a discontinuity and x equals 3. Does everybody understand why? Yep. When the bottom equals 0. So then you say to yourself, is that a whole or vertical asymptote? Good. So these are x equals 1. The x minus 1 didn't divide out, so that's a vertical asymptote. So you'd say x equals 1 is a vertical asymptote. And then x minus 3 doesn't divide out either, so we also have a vertical asymptote at x equals 3. Now, holes, there are none. Let's go over to our graph and draw those in. So go to 1, x equals 1, and draw in your asymptote vertically and 3. Now moving on to our horizontal asymptote. That is when you divide the polynomials. I always go back to this when it's before we factored it out so we can look at the leading terms. Does that make sense, everybody? So x divided by x squared divides evenly 0 times. So our horizontal asymptote is at y equals 0. Let's now draw that in. So we could tell our domain for sure, because I'm telling you right now, your graph will never ever cross the vertical asymptotes, because it can never equal 0. The bottom cannot equal 0. Yep, negative infinity up to 1, from 1 to 3. Yep, because isn't 2 okay? Isn't any number between 1 and 3 okay? As long as it's not 1 or 3, it's okay. And then from 3 to infinity, also. So this is how in regular you would write it. Domain is x cannot equal 1 and x cannot equal 3, but any other number works. Now, if you were in honors, which I really think you guys are really at the same level, then we would say negative infinity up to 1, not including 1, union between 1 to 3 is okay, 1 to 3, union, and then from 3 to infinity. Your pre-calculus teacher will have you do it in interval notation. Everybody good with that? I would practice that if I was you to prepare myself for next year. Okay, and now let's just go ahead and start graphing. So from here, guys, we are literally just plotting points. We've done the hardest part probably. So let's make sure that we're really smart about which points we plot. Is there going to be an x-intercept? Isn't there an asymptote on the x-axis? So will it ever intercept the x-axis? No, so we're not going to do x-intercept. I'm going to cross out x-intercept. Is there going to be a y-intercept? Yes. So that's when x equals 0. So let's plug in 0. I like to plug it in to the original function. Plug in 0. 0. Everybody quickly calculate this for me. So type in 0 plus 3. I'm going to do it right here. 0 plus 3 over 0 squared is 0, correct? Do I need to write that in? Minus 0, 4 times 0, 0 plus 3. So really we're doing 3 divided by negative 3, which is negative 1. Am I correct? 3 over 3, yeah, that's not negative. Sorry, 3 over 3, which is positive 1. Okay, so over 0 up 1. Let's graph that point. Over 0 up 1. Now we know that on this side of the graph over here, from this, sorry, I'm going to draw that. From this asymptote back, we know exactly what the function looks like, correct? It's up in this region, so let's draw that in. So I'm erasing this. Now looking at this, we have done everything that's required. Our x, we just found our y-intercept. We don't have any x-intercepts. So then after that, you can plug in any points you want. Let's think smartly though. Don't we not know what's happening on our graph between these x values? So let's plug in some values in between those asymptotes. Does that make sense? Let's plug in 2. There you go. Do you want to see, does everybody know how you could just use your calculator to give you that value, some whole number values? You go to Y, do you need me to teach you? We already all know. You go to Y equals, type in the function. Now here's the trick though. If you're going to use your table of values, you've got to type it in your calculator what's on top with parentheses and what's on bottom in parentheses like that. Do you need me to show you? Anybody? I would love to. We're all good? Then you should all be doing it right now if you're all good. Okay, so 2, negative 5. Okay, and Riker got that one by hand. Over 2, negative 5. I trusted you. I just wanted to make sure because when we want to make it as easy on ourselves as possible, correct? Well, we're going to want, so we're not going to want to use, here's the thing. You're going to want to be really careful because your pre-calculus teacher might take away your calculator. So we are going to want to test some more values here in a second. Let's test, so while we're at our table of values, let's test this side of the graph because the in-between is a little bit harder. So give me a 0.4. What's 4 at, guys? 2.3. So we're going over 4 up 1, 2.3. Did everybody get that? Yeah. So we know that on this side of our graph, it's going to look something like this, correct? Now the in-between is what's a little bit hard because notice it's right in between those asymptotes. So where is it hugging? So you got to actually think about this one a little bit more. shouldn't we plug in a point maybe halfway between here so we know if it's like back here or you know what I mean? Let's plug in that's like 1.5. Let's plug in positive 1.5. You'll have to do that by hand. Your calculator doesn't have the table of values with decimals. So everybody type in 1.5 and tell me what value we get. Yeah, but if your calculator, if your teacher took away your calculator, then, which is very likely, then you would have to graph this by hand. So who knows if it comes down and goes up like this, because it can cross and go up. Sometimes they will. So that's why we're just going to test some values, because we just have 2 extra steps here. So plug in 1.5. We've got to plug this in correctly. -6. Perfect. So -6. So go over 1.5, go down 6. Perfect. So now we do see that this is now coming down like this. Does that make sense a little bit? Okay, and then let's plug in 2.5 to see how, I don't know if this is coming up, because it could. It literally could come up like this and follow that asymptote. Yeah, so we don't know it's coming down like this. We cheated and used our calculator, but your teacher very well take away your calculator. Maybe I will. So that we're showing that, seeing if you can do it all by hand. So let's plug in 2.5 quickly. What do we get? You got to do it correctly. Did we get -7 point some? I'm just going with it. I haven't calculated it yet. You guys are my first class. Okay, so over 2.5 down -7 point something. So we do know it's then coming down and hugging this asymptote. Everybody good with that? Okay. Okay. So our range on this one, we've already done our domain. Our range on this one isn't okay, so it's growing upwards forever, correct? This one's a little bit harder. This was a hard example. So it's growing up to positive infinity forever, so we know that it will be going up to positive infinity. And then isn't it also, but it's not between those values for y, correct? This one was quite an advanced example here for range. Can we just not do the range on this one because that's way too advanced for us to think about? I mean, it's not going to be, we're going to do range on the next one. This one I made up and didn't think very much about. But let's think about, okay, so let's think about it. It's growing up to positive infinity. There's no graph from here down, correct? So then our graph starts at -5 and then grows to negative infinity. So you just say from 0 to positive infinity and then from -5 to negative infinity. Does that make sense, everybody, a little bit? Okay. All right, well, they won't all be that hard. Here we go. Let's do another one. All right, we got to know the Okay, so here we go. Let's quickly, we look for our discontinuities. So factor out the bottom. It factors to be x -4. You're right, we could get it started pretty good. And x + 4. Does everybody understand? So then our discontinuities are at x = 4 and x = -4. Question now, are they wholes or vertical asymptotes? They don't divide out, so they're vertical asymptotes. Vertical asymptotes. So let's go to 4 and -4 and draw in a vertical asymptote. Okay, and there was no holes. So we've already stated that, and there's no holes. Let's do our horizontal asymptote. 1 divided by x² does not divide at all. So 0 times. So our horizontal asymptote is y = 0. Draw that in. And now we're just plotting points. So this one's going to be very similar to the difficulty level you're going to see on the test. X and Y. So look at it. Is there going to be an x-intercept? No. True. Is there going to be a y-intercept? Yes. So that's when x = 0. Plug it in. Don't we get 1 over, so 0 squared, correct? Is not 1 divided by -16? What's the decimal? Hurry. 1 divided by -16. -0.02, so barely up any. So we're going over 0, down -0.02. Now let's plot some points. So everybody, let's all go to y = very quickly. In parentheses, okay, 0.02 and 0.06 will look about the same, so I don't need to fix it. Does that make sense, everybody? Okay, so go to y =. Everybody, go to y =. Type it in just like this with parentheses. 1 divided by parentheses x² - 16. Why? Because I'm trying to plot points. I'm going to plot x, y points on this side of the asymptote. Let's do -5. What is -5 at? .1. So negative 5 up 0.1. So we know it's in this region, this positive region. Does everybody understand? So I'm going to erase this. I was just showing you. Okay, now let's plot some points. Now we don't know from here over. So what's negative 3 at? Negative 0.1. So negative 3, negative 0.1. So down barely any. Okay, what's negative 2 at? Negative 0.08. So negative 2, negative 0.08, which is even down less, correct? Than the previous point. Okay, and then what's negative 1 at? Negative or positive? Negative 0.06, okay? And then, okay, so we know kind of what's happening. I kind of am wondering here if this is it's gonna probably come down and follow this asymptote. Because it's kind of wrapping and getting closer and closer, so I'm gonna draw that in. Now let's test this side, because it might come up, it might go down. What's 1 at? We're just plotting points, guys. What's 1 at? 3. Negative 1.6. So over 1 down, negative 1.6. So it's coming down, correct? What's 2 at? Negative 3. So over 2, negative 1, 2, 3. I'm pretty confident now that it's definitely going to come and hug this asymptote. Is everybody good with that? Okay, now let's test this side. We're almost done. Give me 5. What's 5 at? Hurry. 9. Over 5 up 9. Sweet. So now we know that this is in this region. And we're done. We did a whole nother one in just a couple minutes, but I better erase this. Because that was just... You can do it. So that's it. So lunch is over. So we will divide our we got to factor it out first. So looking at this one, we have x plus 1 over, we'll multiply to be negative 6, now it's up to be negative 5. So that'll be x plus 1 and x minus 6, correct? That's a negative 6 right here. I just had to draw it with my, that's a 6. So we factored out the bottom. So then you say, what are my discontinuities? When x equals negative 1 and when x equals 6. What kind of discontinuities are they? This one is a whole, because it divided out. Ding, ding. And then so at negative 1 comma something, there's our vertical asymptote because it doesn't divide out. So we go draw in our vertical asymptote, but x equals 6. And then we'll draw our whole in a second. So we've got to figure out, it's at negative 1 comma something. So our simplified function is 1 over x minus 6. So we'll plug in negative 1. That's 1 over negative 1 minus 6, which is negative 1 over 7. Our whole is at negative 1 down some value. So negative 1 down a little bit and put a whole. So that's a point on our graph, just a whole. That is just a point on our graph, like all other points, it's just a whole. So now let's figure out our horizontal asymptote, which is dividing the polynomials. It divides 0 times, right? X divided by x squared is 0 evenly. So y equals 0, so we'll draw in our horizontal asymptote. And now we're going to say, okay, now we're just plotting points. Once again, x, y points is what we're plotting. There are no x-intercepts because the asymptote's on 0. The y-intercept is what we will on a graph next. So that's when x equals 0. So I like to just plug it in up here because it's easier to see. So won't that be 1 divided by negative 6 because those all become zeros right here? So 0 and negative 1, 6. So over 0 down. Okay, perfect. So we're down that. Okay, so now we can see here what's happening. Now we can just plot some more points. Like, let's say we're not comfortable with knowing exactly what's happening, then plot some more points. So type into your calculator, go to y equals, type in this. In parentheses, I like to type into my calculator the non-simplified functions, but really either will work actually. So we can type this into our calculator. We'll get the same xy points. They're the same function, one's just simplified. So give me some more xy points. Maybe will someone quickly do that for me? Yeah. Second table, second y equals. Okay, I'm just going to do it because nobody's really telling me anything. So we're typing in 1 divided by x, 1 divided by parentheses. You've got to put in parentheses. I'm going to type in a simplified one, x minus 6. So I'll do second table. So now give me some whole number points. Over 5, negative 1, correct? Over 5 down 1. So we know our graph must be coming like this, close to the asymptote, correct? What's 7 at? I'm plugging in. I want to know what's happening on this side of the graph. You guys all get that, right? What's 7 at? Okay, so then it must be up here. And we're done. That simple. So our domain would be x cannot equal negative 1 and x cannot equal 6. That would be the regular answer. And if you were an honors, you'd say negative infinity up to 6, 6 to infinity, and then x cannot equal negative 1. Does everybody understand? And then our range is going to be from negative infinity up to 0, 0 to infinity. Everybody seeing it? Or you could say y cannot equal 0. That's what our horizontal asymptote is. Everybody good? Okay, last one. Let's do a number 1 on the worksheet. Okay, so we're going to figure out, the first step is figure out your discontinuities. That's when the bottom equals 0. So we've got to factor this out. So factor out x squared minus 4. That becomes x plus 2 times x minus 2. Everybody, we should be that quick at factoring. Are we about at that point in life? Okay, and then on bottom, we would have to long factor, but I'm not going to take the time to do that. I'm going to ask somebody that's got it to tell us what it is so we don't have to waste time. So 6 and 4, but then we have to long factor it, right? What did you get on bottom, Gavin? So we don't have to all do it. Nope. No, that's wrong. You cannot quick factor this. Your A value is 2. Okay, let's just do it then. I promise you're wrong, but we can go through it. So we drop and break. So you were right, our factors are 6 and 4, correct? Well, multiplies to be 24 and adds up to be 10. Is everybody following? 2x squared, and then we have, we decided 6 and 4, so plus 6x plus 4x plus 12. So we'll factor out okay, if you would have said 2 times, then I would have seen that you were almost correct. You're just forgetting something in your answer. Well, let's see. So we'll factor out a 2x, left was x plus 3, correct? Factor out a 4, left was x plus 3. So we have our x plus 3, and then we have 2x plus 4. Does that keep factoring? We'll factor out a 2. So we have our 2, then we have our x plus 3. I factored out a 2, but put it in front. And x plus 2, but you didn't say 2. X plus 3 and x plus 2. So I was confused. Okay, so we have a 2. Does everybody understand? An x plus 2 and an x plus 3. Okay, got it. Now I'm seeing where you guys are coming up with that. So I'm going to erase all that now that we went through that. Okay, so now we can say our discontinuities are when the bottom equals 0. 2 is never going to be 0. So x equals negative 2, correct? And x equals negative 3. Are they wholes or vertical asymptotes? Those divide out. So there's a hole at negative 2 comma something. We'll figure that out in a minute. And then there's a vertical asymptote at negative 3 because it didn't divide out. Draw that in. Negative 3, draw in your vertical asymptote. Okay, let's figure out the whole. So now that they divided out, we're left with x minus 2 on top, 2 and x plus 3. We're going to plug in. I'm just literally saying, what's my function at negative 2? So negative 2 minus 2 is negative 4, correct? I'm plugging in negative 2 for x. Negative 4 over 2 times, what's negative 2 plus 3? 1. So 2 times 1 is 2. So won't that be negative 2 as well? So go to negative 2, down 2, put a hole in there. That's just a point on our graph, but it's a hole. Now let's do our horizontal asymptote. Let's divide our polynomials. 1x squared divided by 2x squared is 1/2 evenly. So y is equal to positive 1/2 is our horizontal asymptote. Go up 1/2 and draw in your horizontal asymptote. Okay, so now we are just going to graph the x and y intercepts here because we do have both on this one. X-intercept is when y equals 0, and our y-intercept is when x equals 0. So plug in zeros. Let's go to yep, the y-intercept is positive 1/3. You plug in 0. Let's all do it. So that's when x equals 0. Plug in 0. So that would be -4 divided by 12, correct? Positive 1/3. 1/3. Okay. So now the y-intercept, let's do that one because I think some of you are going to have a hard time. So we have x is equal to x squared minus 4. We multiply both sides by, over 2x squared plus 10x plus 12. Don't we get a common denominator? So we'll multiply by this over, no, because this is 1, correct? So then we'd have to re-multiply back together to distribute it. But this one's easy. Think about it, guys. Use your brains. Anything times 0 is going to be 0. So don't we just have 0 is equal to x squared minus 4? So isn't that really 0 is equal to x minus 2 and x plus 2? Because that's the factored form, right? Of that. So x equals 2 and x equals -2. Isn't that how we solve when it's set equal to 0? So it's crossing at 2 and -2, but so it's crossing at positive 2 and it's crossing at -2. So it must, wait, what? What am I missing here? The x-intercept when y equals 0. That is not going to happen. So why is that not going to happen? What do you, right here? Either way though, if we would have added 4 and then square rooted it, we would have got plus or minus 2, correct? Okay, let me grab my key. I'm just trying to think. I went mind blank for a second because I've had to think so hard. It's not, here's why it's not -2. Okay, this is why we throw out -2. Don't we know there's a hole at -2? Yeah. So it can't ever be -2. Correct, everybody, before we divided it out. So I say, okay, I'm going to throw out that answer because we can't divide by, we can't plug in -2. That was one of our restricted values. Does that make sense, everybody? Okay, now it's making more sense. Sorry, I don't know how come I went so mind blank. So we would say, sweet, now look, don't we know on this side of the asymptote what our graph looks like? There's a point, there's another point. Yeah. So it's following those asymptotes. And then, let's see, we have no idea what's happening on this side of the graph, so let's just plot some x, y points. So plug it into your calculator and give me some points. Like -4 is a great point to test, or -5 or -6. So -5 or -4, I don't care.
You don't include the ones you crossed out, right?
It'll say error at the ones we crossed out. What do you mean the ones we crossed out?
Like we don't put those in the one you crossed out. Do we still put them in the white?
We never were, I don't take the question.
So, like x plus 2, we crossed that out, so if I type that in, the y equals so
oh, you can type in the simplified answer, this,
yeah,
or this. I just typed this in, but either or, and use parentheses. Guys, don't just rely on Riker to do it for you.
Yeah, you really should. Honestly.
Guys, if you have no idea what you're doing, you should be saying, wait, now what am I supposed to be doing? Not just sitting there waiting for everybody else to do it. If I'm not making sense, I don't know. It was, no, I just didn't go back. It was +2, only +2. Yeah, yeah. Okay, yeah, sorry about that. Okay, does anybody have some points for me on this side of the graph? Yes. Yeah, it should be -1/3. Good fix. Sorry, I'm feeling really rushed with the bell, so I'm not teaching, and like you guys, like it's crazy with lunch. What? -5 up 3? Okay, -4 up 3, correct? So we are know enough though, right, from that point that it's going to come like this. Okay, so we've graphed our first one. Questions? You guys are good to go with graphing these? That was my last example, so you've got to be. Unless you need this one. Do you need one more? Okay, then let's fly through it. Let's do the domain and range back on this one. So domain is x cannot equal -2, right? And -3. X cannot equal -3. Our range is y cannot equal 1/2, correct? Yes, but you need to do that. It will be on the test. So y is equal to 1/2. Range is y cannot equal. So all real numbers except for -2 and -3 for domain. All real numbers except for 1/2 for range. Does everybody get it? Okay. That was saying that x cannot equal -2. See, x -2 is a whole.
Are we not going to put the whole?
What do you mean? If you get it, then do. If not, then just don't. If you're above and beyond, then that would be great. Okay, here we go. Let's do this one. So let's find the vertical asymptotes. What is it? X is equal to? No. No. So if you want another one, I'm doing this one. Do you need another one or no? Okay, so let's go through this 10 times quicker than we have been. What is the vertical asymptote? -5. Why is it not a whole? It doesn't divide out, so there's no holes on this one. So you'll go to -5 and draw in your vertical asymptote. Okay, let's find our horizontal asymptote. Divide the polynomials. They divide evenly. What do we get? Y is equal to 1. The leading terms divide evenly, I should say, correct? Okay, so y equals 1, so we go up 1. Okay, now we're just plotting xy points. Notice there is no asymptote on the y-axis, so there is a y-intercept. There's no asymptote on the x-axis, so there's both. So we're plotting points, specifically x and y-intercept. So plug in 0 for x. That would be -3/5, correct? Which is what decimal? -0.6. So go over 0, down 0.6, correct? Roughly right there. Now plug in 0. So we have 0 is equal to x - 3 over x plus 5. Yep, because when we multiply by x plus 5 over x plus 5, 0 times x plus 5 is nothing. So we have 0 is equal to x - 3. Well, then what would we do? So 3, 0. So our x-intercept is over 3 up 0. Sweet, that looks right. Now we know in this region from this half over that it's like this, correct? Okay, and then from this half over we have no idea. So let's plug in -6. Or do it in your calculator, you know what I'm saying, right? We're just plotting some points. So now I'm just going to do like -6 because that's on this side of the asymptote. Is it up here or is it down here? 9. So -6 up 9, so then we know it's in this region of the graph. And we're done. Everybody good? Okay, start practicing. You have a little bit of time. Notice the back page, you don't have to graph it. Just says state the discontinuities, vertical asymptotes, horizontal asymptotes, x-intercepts, and then what's the domain?
I have a question.
Do I need to go through the domain or we get the domain range good enough? Okay.